Sonification is the process of giving data an auditory representation for the sake of data analysis. In other words, it gives non-musical things a musical parallel in order for us to parse through complex data. If I'm looking at a picture that you can't see, I can describe it to you using words. I've just transferred the image into an auditory representation. And while that may not be a perfect analogy for sonification, perhaps it may help in the way of definitions. Audio can have certain advantages over visual. That's because we perceive sound different than we perceive images. Audio happens in time, in colors, in space, and in frequencies. And all of these differences can give the listener a different perspective on the data. You're definitely familiar with some simple everyday forms of sonification. A clock will tick at 1 second intervals and will chime at either 15-minute or 1 hour intervals. This gives an auditory cue to the listener, which represents a piece of data. In this case, the passage of time. Another early example of sonification is the Geiger counter, in which clicks represent the presence of radioactive material. But let's look at some more complex data sets. How does sonification work when the data is dense? The goal is to be as faithful to the data as possible. We aren't constructing musical pieces that are just inspired by the dataset. No, we want a musical representation that is precise as possible. So, data points are mapped onto a particular auditory representative. This could be pitch, it could be timbre, such as an instrument. It could be any number of things. Tempo can be a variable for data, although it's often more helpful to have a constant tempo, so that the data has a certain groove, especially if one of the data points is days, months, or years. Perhaps we have a data set that goes up and down. In this case, pitch could be a really good indicator. Furthermore, if we want it to represent equal increments, the whole tone scale can be really useful. For example, one of the ways that sonification is used is for stock market analysis. We could look at the data for a particular stock by assigning data points as specific pitches in the scale. Although here recently it probably sounds a little more like this. We could also pit 2 or more stocks against each other. We can differentiate those stocks by using different instruments for each stock. Of course, sonification has other applications than just financial analysis. In 2017, composer Wayne Grimm and the Kronos Quartet used data from various telescopes to sonify the 2017 total solar eclipse. And perhaps more relevant to current events, sonification has proven useful in DNA analysis. For example, we could map each of the 4 mononucleotide bases onto 4 musical pitches. This could produce a highly repetitive pattern, which means that aberrations in the pattern could indicate something like a genetic mutation. Scientists and musicians have recently collaborated to create a sonification of the current COVID-19 virus. This sonification is an audio representation of the amino acid sequence and the structure of the spike protein which gives the coronavirus its name. I've placed a link in the description. This sonification will hopefully give researchers a new perspective on the structure of the virus, and will allow them to study it quicker than just simply looking at the data. Eventually, this might even provide scientists with some insight on how to prevent the virus from infecting human cells. Hey guys, just a few footnotes from this episode. Number 1 is that sonification is not meant to necessarily be good or beautiful music. The point is actually to faithfully represent the data. So the goal is not to be beautiful. In fact, good sonification may be dry and very repetitive so that the listener has the ability to listen for patterns within the data. Number 2, the point is not to characterize the object of the sonification. For example, with the coronavirus, the goal is not to give the virus necessarily evil-sounding music because the virus is bad, nor is this meant to say that that's what the object actually sounds like, as might be the case with either, stars or planets, or even, DNA material. That's not what sonification is about. It's not to say that this is what the object actually sounds like. And 3, this video is an overview of sonification. It's not necessarily an analysis of the sonifications that were presented as examples to say whether or not they were good or bad sonifications. They were just examples. So, hope you guys enjoyed, and I'll see you next time. Thanks for watching this episode of 2 Minute Music Theory. If you enjoyed this video, please like, subscribe, and turn on notifications so you don't miss an episode. Also be sure to check out my other channel, Jesse Strickland Music, which is home to all of my compositions. And if you're the kind of person who uses social media, be sure to connect with me over there.